Okay, this is exciting. We are about to witness a first. For the first time in human history, we are about to crash a spacecraft into an asteroid on purpose in an attempt at planetary defense. And we don't even need Bruce Willis or Ben Affleck or Steve Buscemi to make it happen. This is what it looks like right now. This you can see, well, over there, there it is. That is the asteroid Dimorphos and Didymus. Didymus would be the big one. Dimorphos is the small one. That's what we are aiming for, and we are sending a satellite right now 14,000 miles an hour towards it to crash into it. We're going to keep an eye on that as it happens. More on that in just a second. But we also have an Eagle High alumnus involved in this project. Dr. Harrison Agrusa graduated from Eagle High in 2013. He graduated from the University of California in 2017, where he studied physics and astrophysics. And just recently, he earned his PhD from the University of Maryland. Well, today, he's watching that collision, well, like the rest of us are, only he's doing it from the Johns Hopkins Applied Physics Lab, the place where they built that spacecraft, that satellite that's going to crash into that asteroid at about 14,000 miles an hour, like I said. They call it the Double Asteroid Redirection Test, or DART, because double asteroid, I should say, because it collides with an asteroid that happens to be the moon of another asteroid. Redirection because they're trying to change the orbit of that smaller asteroid. And test because, well, that's what this is. We're not in any danger here on planet Earth. We're just seeing if we can do it should we need to later. So we thought we'd get Harrison to help us understand what DART is.
In a galaxy where asteroids have pummeled planets for billions of years, now one planet strikes back.
Yeah, it sort of sounds like the stuff movies are made of.
NASA will test an asteroid deflection technique.
Asteroids, spacecraft, collisions, basically bumper cars in space.
NASA's double asteroid redirection test will intentionally ram itself into an asteroid.
Oh, it's dramatic, but in reality, without the melodramatic music. Let's let Eagle High graduate.
Engineer, so I'm not on the spacecraft building or the navigation.
Harrison Agrusa.
I'm on the investigation team, which you can kind of think of as like the science team.
It make sense.
So the smaller asteroid Dimorphos is orbiting around in about a circle around Didymos. And then once we hit it, we're going to basically hit it head on. So it's going to slow it down so that it'll slow down and its orbit will now shrink and it'll become closer to Didymos, its parent body. And so once we impact it and change its orbit, my job is to run all sorts of computer simulations to predict precisely how that orbit will change.
So just to be clear, this isn't a case of this asteroid is threatening Earth and we're out here to save it. This is a test.
Yeah, so this system was specifically designed as an ideal target for a test mission because we know its orbit around the sun very well. So we know it's not going to be a threat to Earth. We know that we won't make it a threat to Earth. So it's really like this nice, full-scale laboratory in space. We're testing this. We're demonstrating that, yes, in fact, we can build a spacecraft on a short time scale, crash it into an asteroid to change its orbit so that, if we ever find an asteroid that is on a collision course with Earth, we've already done the practice run.
Okay, so what happens if you do alter this? I mean, is it like that whole butterfly wing kind of thing where way down the road it's going to create some sort of chaos?
Yeah. I mean, obviously we can't predict everything, but we have the heliocentric orbit of this binary asteroid. So we know its orbit around the sun with incredible precision. We don't know exactly, but we have a pretty strong idea of how hard we're hitting it. And the spacecraft is pretty small and, it's much smaller than the asteroid. So we're only changing the velocity of the asteroid by a very, very small amount.
Harrison says it'll be like a vending machine smashing into a football stadium.
That football stadium is not going to move very much. You know what I mean? So much so that it's going to actually be incredibly hard to even measure how much its orbit around the sun has changed, right? So
still, as small as that impact will be, it will leave a huge mark on planetary science.
Well, I mean, it's got to be pretty cool to be a part of the first time this has ever been. Never happened.
Yeah, it's the first time we're demonstrating that humans can deflect an asteroid, right? If the dinosaurs had a space program, they'd still be walking around today. Yeah, you can't stop earthquakes, can't stop hurricanes. This is one of the volcanic eruptions we can't do much about, but an asteroid is the only thing we can stop if we put the effort into it to find them and deflect.
You hope.
Yeah. In theory, it's the only thing we can deflect. It's a matter of, we got to detect them first.
That's true. Do you consider yourself a planetary defender then?
Yeah. Anyone that's worked on this, you can actually go onto the APL website and take a quiz and anyone can become a planetary defender. Yes, exactly. Love it.
So we're like the same. We're like the same people.
Yeah.
Harrison.
Yep.
Okay, so this is it, right? This is it hitting it. It's at 5:15. This is kind of a replay. I think it just happened about a minute ago. It's supposed to hit at 5:15 straight up, our time. There it is, approaching the asteroid. And then we're going to lose contact with it because obviously it crashes. And it's sending us a picture a minute as it's happening live. Never happened before in NASA history either. They were watching something happen live as it happens, and there it goes. That's the crash. And that's the last image we see before that satellite, that spacecraft, crashes into that asteroid. Okay, so Dr. Agrusa got his doctorate 2 weeks ago, and it was about this very experiment. He made all these predictions in his thesis, so now we get to see if he was, well, correct. His work begins right now, after that crash. The goal is to alter Dimorphos' orbit just a little bit. Before today, it took about 12 hours to get around its Didymos planet, or I should say asteroid, the one that it's kind of married to. He told us about 11.92 hours. And if this test works, it's going to be slowed to about 11.8 or 11.7 hours. And they're going to use telescopes to kind of gauge the success. And then 4 years from now, in 2026, the European Space Agency is going to send a mission to that same space, in space, and they're going to be able to send us back pictures of the crater created by DART. So one more look at it. Do we have another look at it? No, it's on. It already hit. It's done. They're celebrating. We'll be right back.